Welcome to the complex architecture of modern industrial manufacturing. Today, we are examining the engineering required to build a state-of-the-art brake fluid plant. This requires the expertise of Fossil Wood Engineering Services and Contracting, a professionally managed multi-dimensional engineering company headquartered in Chennai. Fossil Wood's core competency lies in delivering fully integrated industrial solutions. From specialized plant design to executing full turnkey services, they engineer facilities built to handle highly volatile and sensitive chemical processes. This map highlights Fossil Wood's footprint. Maintaining strategic nodes in Chennai, Dubai, and Magdeburg, Germany, they deploy specialized teams across critical industrial hubs. Over 8 years, this network completed 30-plus large-scale projects, operating under strictly certified ISO 9001:2015 quality management systems. Executing chemically volatile process plants requires both global scale and extreme operational rigor. The infrastructure must be exact. Fossil Wood ensures this exactness by controlling the entire life cycle of the facility through a full-spectrum engineering, procurement, and construction, or EPC approach. Phase 1 is engineering. Before a single component is fabricated, the team establishes the conceptual framework, maps out all chemical process constraints, and finalizes the detailed structural and civil analysis required to support the plant. Phase 2 is procurement. Brake fluid manufacturing requires specialized chemical-grade components. Fossil Wood applies a strict vendor qualification and selection process to source materials capable of withstanding corrosive environments. Phase 3 is construction. Dedicated construction management teams execute the build, bringing the theoretical technical specifications into physical reality on the plant floor. Synchronizing these phases into one workflow allows Fossil Wood to maintain the environmental isolation required for hygroscopic chemicals across the entire project lifecycle. To understand why this environmental isolation is necessary, we have to look at the fluid itself. In automotive systems, DOT3, 4, and 5.1 brake fluids operate as highly specialized hydraulic transmitters. They carry the physical force from the brake pedal directly to the wheels. To maintain low compressibility under heat, DOT3 and DOT4 fluids are formulated almost entirely as polyethylene glycol-based blends. This diagram categorizes the fluids by composition, isolating the critical vulnerability of polyethylene glycol. It is highly hygroscopic. This means the fluid actively absorbs moisture directly out of the surrounding atmosphere. Once atmospheric moisture is absorbed into the chemical matrix, the overall boiling point of the brake fluid severely degrades. A lowered boiling point means the fluid will vaporize under the intense friction heat generated during normal braking. Vapor is compressible, liquid is not. If the fluid boils in the lines, the result is a catastrophic loss of hydraulic pressure. The chemical composition required for hydraulic performance cannot be changed. Therefore, the engineering challenge is to architect a manufacturing facility that provides absolute 100% environmental isolation from the moment the raw materials enter the tanks. Fossil Wood engineers the front-end plant design to handle exactly that, scaling secure production capacities from 1,000 up to 10,000 liters per day. The process begins in massive sealed cylindrical tanks. These primary processing units are built specifically for precision chemical formulation. This 2D piping and instrumentation diagram maps out the integrated thermal controls within those tanks. Because BOT standards dictate strict thermal limits for processing, these systems actively manage the exact blending temperatures. Inside, specialized internal agitators ensure the fluid blends consistently. They are calibrated to mix the heavy glycols without causing cavitation or introducing air into the batch. Most importantly, the hermetic sealing of these cylindrical tanks acts as the facility's first impenetrable barrier against ambient humidity. Mechanical precision, operating within strict thermal and environmental limits, ensures the final lubricant meets the chemical requirements of the blend. Once the batch is mixed, the static formulation stage ends, and the dynamic challenge of material transfer begins. Moving volatile chemicals safely across a facility requires an advanced precision piping network that connects all processing units to the downstream storage areas. This isometric view traces Fossil Wood's color-coded infrastructure. Specific blue and red lines dictate exact flow directions and separate the distinct material types across the plant floor. These closed pipes do more than direct traffic. They are engineered to sustain the perfect 100% hygroscopic control established in the primary tanks while the fluid is in transit. To maintain this control, integrated electronic monitoring panels continuously regulate both the pressure and the flow rates of the fluid in real time. Because this network operates under high pressure with corrosive materials, Fossilwood surrounds it with necessary physical safety infrastructure, including yellow safety railings and secure access platforms for maintenance. The piping network functions as an active, continuously monitored extension of the plant's moisture isolation strategy. The final and most environmentally vulnerable phase of the operation is storage and packaging. Exposing the finished fluid to factory air now would ruin the entire batch. Fossilwood navigates this by utilizing integrated packaging facilities equipped with automated conveyor systems for high-volume handling. These automated filling nozzles are engineered to be completely moisture-proof. They rapidly dispense and seal the product into individual containers at high speed. This entire filling process is executed inside a specialized microenvironment that physically blocks out ambient factory air and humidity. Because the fluid is isolated from the mixing tank all the way through the final seal, Fossilwood guarantees a closed-loop production architecture. The final output is over 99% moisture-free. Consistently yielding compliant, high-performance industrial output does not happen by accident. It requires rigorous execution of first-principle engineering constraints. This full schematic visualizes the entire completed system operating as a unified, continuous manufacturing entity. A true turnkey delivery means managing every variable of this layout, from the conceptual pipeline design to the final operational commissioning of the conveyors. By controlling the EPC pipeline, Fossilwood guarantees an output that meets the uncompromising global safety standards required by the Department of Transportation. With a scalable model capable of producing up to 10,000 liters a day, facility owners are positioned to efficiently capture the expanding global demand for high-performance automotive lubricants. True engineering, procurement, and construction success relies on a simple premise: translating deep chemical vulnerabilities into robust mechanical, structural, and procedural solutions. Fossilwood engineering drives every project through 4 core principles: maintaining strict ethical standards, optimizing resources for cost-effectiveness, delivering superior quality, and executing a rigorous safety-first methodology across all operations. Whether you need a highly specialized brake fluid plant or an integrated process facility for specialty chemicals, Fossilwood has the engineering expertise to turn complex requirements into operational reality. Visit fossilwood.com to explore our engineering services, view global projects, and connect with our team to request a quote for your next industrial facility. Thank you for watching.